intercept. So now we want to find the x-intercept. How do I find the x-intercept for any function? We said y equals to 0. So negative 7 raised to x plus 1 plus 49 equals 0.
G of x, negative 7 to the power x plus 1. And f of x is 7 to the power of x, number 1.
Yes, we're talking about this function.
That's not G of x.
So it says you are using 7 to the x to create this function. Find the domain and range and determine the x and y intercepts algebraically. Present the transformations in order of operations for negative 7 raised to x plus 1 plus 49. I gave you the base function in case you forgot.
Okay.
Is that okay?
Yeah.
Perfect. Good. So we did all these problems were done last time. I just wanted to review one more time and see if you remember anything. So I'm not so sure now. It was a good idea or not a good idea. Okay, so how do I solve this? So the test is on Monday, so I'm hoping you're going to look at all these problems again. That's my hope. How do I solve this equation? What is the first step? Very good. Negative 7 raised to x plus 1 equals negative 49, and then? Yes. Yes, I have to multiply or divide by negative 1, absolutely. So 7 raised to x plus 1 equals 7 squared. So therefore, x plus 1 equals 2, so x equals 1. I remember writing negative 1 last time or something like that. And Heather said, wait a minute. And I said, well, if Heather says, wait a minute, then I'm in trouble. Okay, good. So we found 0, 42, and 1, 0 as the x and y intercepts respectively. So now we will, in number 1, the base function is 7 to the x. Then we have 7 raised to x plus 1. Then we have negative 7 raised to x plus 1. And then negative 7 raised to x plus 1 plus 49. So this one is left 1. This one is reflect. And this one is up 49. Of course, I have to present the horizontal asymptotes. Okay, so I start with seven to the x, which remember it's a increasing function on all its domain. It has to cross at 0, 1. Then you said left 1, which means this point moves right here at negative 1, 1. So this is 7 raised to x plus 1. Then you told me to reflect this graph with respect to the x-axis, of course. So the point moves here. And here it is. So this is negative 7 raised to x plus 1. And then you said move it up 49. So I hope you accept this is 49. You can say no, and then I said I'm sorry. I know it's not 49. And then we move everything up 49. So this point will move at 48. And it will cross here at 0, 42. And it will cross somewhere here at 1, 0. So here's the graph. Oops. This is not a straight line. This is not a vertical line. Be careful. It looks like it, but it's not. So this is the final graph. Is there anything else you can think of to review? I will read the topics one more time if you want to write them down. one more time so you know exactly what you should expect. Ready? Graphing an exponential function that we just did a second ago using transformations. Graphing, that's the first one, right? I will just repeat it. Graphing an exponential function using transformations and finding the x and y intercepts algebraically. Is that clear? Okay. Next, using the models of continuous compound interest. Let me write them for you. You don't have to memorize them. They will be given to you in the problem. So I'm talking about this problem, this and this. They will be given to you. This one is for interest compounded n times a year, and this one is for continuous. They will be given to you. So this is another problem. The next topic, exponential or log function, word problems. Like we just had with logistic growth model that we started with today, when the population gets ill. Expanding a log expression, that's the next topic. Expanding a log expression. Next topic, condensing, sorry, that's the next one. Condensing. The next one, exponential and log equations. We had one of each. The next one, a linear or non-linear system, like we started with that x plus y equals negative 11 and something squared plus something squared equals 34. The next one, a system of nonlinear inequalities in which you have to graph and shade in. Gauss-Jordan or Gaussian elimination, you choose, of a system. And then sequences. A general term is given, or a recursive formula, simplifying factorials, and condensing a long sum with a summation notation. The two examples that we looked at a few minutes ago. These examples. Simplifying factorials, this example, the one with the big number, the recursive formulas. Is there anything that you would like to go back to? We have 10 minutes left.
Are we going to have anything about the decay model?
The decay model? So it's the same. Let's take a look at an example with decay, but it's the same with the exponential growth. So it's something like this. It's just that it has minus in front of that. Same thing, the model will be given. No change other than the minus in front here. Let's take a look at a problem. Yes, here it is. Problem 80. On page 537. P of x is 14.7 e to negative 0.21x. Models the average atmospheric pressure, P of x.
That's not, I'm sorry, that's not what I was talking about, I don't think. I was talking about where it's the half-lives and all of that.
No, so this is
This is
exactly
it?
the, yeah, this is
Okay,
the
maybe
same.
it's
This is
over
the same thing. So it's measured in pounds per squared inch. And x is the altitude, and that is in miles. So at the peak of Mount Everest, the world's highest mountain is 4.6, the pressure is 4.6 per squared inch. 4.6 pounds per squared inch. How many miles above sea level to the nearest tenth of a mile is the peak of Mount Everest? So we are told that this is given to us, and we're asked to find the altitude. Very interesting problem. So what do you think about this? What do we have to do? Yes? Yes. So we have 4.6 equals 14.7 e to negative 0.21x, and what do we do next? Of course, we have to clean it up. Thank you very much. And now, natural log to both sides. So we have natural log of 4.6 over 14.7, negative 0.21x. Exactly. And we will find out how high is Mount Everest. Very good. So what is it? So with the graphing calculator, let's do that. So I have natural log 4.6 divided by 14.7, very good. Close the parenthesis and divide by, don't forget parentheses, negative 0.21. So how high in miles is Mount Everest? Yes, approximately x is approximately 5.53 miles. And this is an exponential decay because it has minus in there. Anything else? Can you think of anything else? Can you think of any other topic? Is there anything else that you would like to go back to? Any type of problem?
Model is better than
Yes, very good. Okay, so we are given that in 1980, the percentage was 14%. And we're given two models, f of x, 6.19, 1.029 to x, and g of x, 37.3 over 1 plus 6.1 e to negative 0.052x. So we're given the answer, and they're asking us to plug in, so from 1950 to 1980, we're talking about 30 years. So we're asked to find f of 30 and g of 30 to see which one is closer to 14%. So what I recommend in y equals, put in both functions, 6.19 and in parentheses 1.029 raised to power x. And then the second one, 37.3, there is no operation in the numerator, so you don't need to put parentheses around the numerator, but you absolutely need to put parentheses around the denominator, 1 plus 6.1 times e raised to negative 0.052x, close the parenthesis and close the parenthesis for the denominator. And then go to second in table, and what we want to plug in 30 for both. And we get both answers right away. Since the correct answer is 14, we will select for this problem, we will select f of x. So for 30 years after 1950, this is a better model. I cannot say that it's better for all years, but I can say it's a better model for 1980. That I can say. Is this better?
Yes.
Perfect. Anything else that you can think of? Any type of problem? If it does not bother you to start early, you can. I will be here from noon, but I will be reviewing with them something else. So you may come in like, I don't know, 15, 20 minutes early. If you'd like to start early, but you can also stay after if you don't have a class, of course. If you think you need more time.